Welcome back to the course Asynchronous Programming in C#. I'm Philip Ekberg, and now we are going to talk in detail about using the Task Parallel library in .NET. The Task Parallel library, commonly also referred to as the TPL. In this module, we'll talk about how to introduce tasks in our applications. This will essentially allow you to run heavy operations on a different thread. Without using the async and await keywords, you will discover ways to obtain the result, work with the exceptions, and run code after these operations complete. You will even see how you can introduce different continuations, depending on if the task succeeded or failed. You will also learn about canceling a task, which may sound a lot easier than it actually is. To explore and fully understand tasks, we're going to implement a way to load some file contents from our disk. First, we'll do this in the normal, synchronous way, and then we'll proceed to do this asynchronously. The data store included in the project already implements a way to asynchronously work with a file system. But let's take an alternative approach to learn about tasks. Let's continue to do all our work in Search Click. And for now, we are going to remove the call to get stocks, which we introduced in the previous module, as well as removing the async and await keywords. Provided with this project is a comma-separated file, which we are going to open and then parse. You can use the file class to read all the lines from a file. Each line will then be parsed and stored in a list of stock prices. We are going to iterate over each line in the file, but we'll skip the first row because that contains the headers. I've included a helper to parse the comma-separated values into a stock price instance. This can now be added to the list of stock prices. We can then use LINQ to find the stock identifiers that we're looking for. And finally, the data grid in the application can be updated with the stock prices. There's really nothing that we've written now that's asynchronous. If you run the application, you can see that it takes a bit of time to load all the data and populate the data grid. While it loaded the data, the application freezes, and you're unable to perform additional work. The reason for this is because you load a very large file without using an asynchronous approach. This is what takes the most of the time. All of this runs on the UI thread. No wonder the application is locking up. To make this asynchronous, coming from the first module, the first thing that you probably want to check is if there's an asynchronous version of read all lines available on the file class. In this case, we are in luck. As of a few versions ago, .NET includes an asynchronous version of this method. We are going to assume that this does not exist and explore alternative approaches, as in a lot of cases, we might not be as lucky to have an asynchronous alternative available. There are alternative ways in the .NET framework to allow you to work with the file system in an asynchronous manner. However, in a lot of cases, this is situations that you have to work with. You end up using libraries that provide a lot of great functionality, but they don't expose any asynchronous versions of their methods. Therefore, we need a way to introduce asynchronous principles without relying on the libraries to provide this for us out of the box. So how do we approach this? One way is to introduce a task. We encountered the task in the previous module, but we didn't spend too much time talking about it. The task is a way to represent an asynchronous operation. It exposes functionality to allow you to perform all the necessary operations that you'll need to. Here are a few things the task allows you to do. You can schedule work to be executed on a different thread. It provides a way to get the result from that asynchronous operation. You can subscribe to when an operation is done by introducing a continuation. It can even tell you if there was an exception. There's much more to the task than this, but we'll get to that later. The task provides a static method called run. This method is used to queue work on what's called a thread pool. Simply put, the work will be executed on a different thread. You can point it to a method, pass a function, or an action that will run on that different thread. There are two versions of task.run, the generic version that will have a return value after it has completed. We don't need to explicitly use the generic version because if the task returns something, the compiler can infer the type. Task.run returns an instance of a task that represents the asynchronous operation. Continue to the next clip to learn how to apply this new knowledge of task.run to move the synchronous version of the code into a new asynchronous operation.